Molar mass. All right. One of the things that we've looked at so far already is we said, hey, we can find out how much 1 mole of an element weighs. For example, if you look at carbon, okay, look at carbon real quick. If you find carbon, you'll find that the what we call the atomic mass, okay, was equal to 12.01, okay, and that is the amount of grams per 1 mole for that substance. Now that was just for carbon, and we've done grams to moles conversions, moles to atoms conversions, if you remember right. And so we're going to take it one step further, and we're not just going to look at an element, but we're going to look at how much would 1 mole of a compound weigh. Okay, so we're going to find what's called the molar mass. Now, the easiest way I think to remember this is, okay, how much does a whole compound weigh? And so we're going to find that out via the molar mass. All right, so how are we going to do this? Well, first thing that you're going to do when you get a formula like the one you see here, which is C12H22O11, is I just go ahead and I write down what I have. So I have carbon here, and I have hydrogen, and I have oxygen. And then what I do is I say, okay, well, how many atoms of each do I have? Now, you look then for the subscript. So, how many carbons do I have? Well, you should see we have 12 of them. How many hydrogens do I have? I have 22. And how many oxygens do I have? I have 11. And so that gives us just how many of each you have. Okay, so first thing, write down the symbols. Second thing, write down how many of each element you have. Then what you're going to do is you need to look up how much each of those elements weighs. Okay, so for example, carbon, I have 12 of them, and how much does each of them weigh? Well, if you look on your periodic table, it says each of them weighs 12.01. Okay, now let's go down to the hydrogen. Hydrogen is 1.00794, so that we just write down 1.01. Oxygen is 15.99994, which then rounds up to 16. And so that is how much each of those individual ones weighs. Now the next thing you need to do is you need to multiply how many you have by the weight. Okay, so for example, for carbon, you need to take 12 times 12.01, and when you do that, you should get 144.12. That's how much mass the carbons bring. Okay, then you have your 22 hydrogens times 1.01, which should give you 22.22. And last but not least, you have your oxygen, so you have 11 times 16, which gives you 176.00. All right, now what we need to do is we need to, of course, our whole purpose was to find the mass of the whole thing. So what we're going to do is we're going to add up the carbon plus the weight from the hydrogen plus the weight from the oxygens. And when we do that, you'll get a number of, hold on just a second, you'll get a 342.34. Now, the unit for that is grams per mole. Grams per mole. And that is how much your whole compound weighs. Okay, so your C12H22O11. And again, whenever you're finished with it, make sure you go ahead and put a box around it. Let's do another one here. Maybe one that's got like a polyatomic ion in it. Let's do calcium hydroxide. CaOH2. All right, now, first thing we do, we write down what we have. I have calcium, and I have oxygen, and I have hydrogen. The next thing that we do is we go through and we write down how many we have. So how many calciums do we have? Well, there's no number below it, so that means, again, that we have 1. How many oxygens? Well, there's no number below that oxygen, but remember, if there is a number outside the parentheses, you have to multiply by that. So we have 1 times 2, which gives us a total of 2 oxygens. Hydrogen, again, we have no number below it, so there's 1, but we have to multiply by the number outside the parentheses, so we have 2. Okay, after we find out how many of each element we have, we have to find out what the mass is on the periodic table. And so for calcium, we have 1 calcium and it weighs 40.08. We have 2 oxygens and they each weigh 16. And if you look at our hydrogen, they weigh 1.01. And then what we need to do is we need to go ahead and add them all up. And so, or excuse me, multiply first and then we'll add them up. We get 40.08. Take our 2 times our 16, which should be our 32. And then our 2.02 from our hydrogen. After that, we need to add them all up. And we should get 74.1 grams per mole for CaOH2. So don't forget, when you have a polyatomic ion, make sure you're aware that if there's a number outside that parentheses, you need to multiply by that. Okay, we're going to move on to a little more of a difficult problem. I shouldn't say it's more difficult. It's just that it has in it something that you probably haven't seen before. And this is something that's called a hydrate, okay? Now it's going to look something like this. If you have Na2CO3, and then you have this dot, and then you have this H2O thing. Well, what that's saying is that this is a hydrate, and this is when you have a chemical compound, Na2CO3, sodium carbonate, but we have 10 water molecules that are also joined in with it. And so we have to make sure that we take in the water into account. Now, when you're doing this, I would suggest that you remember one key thing. And this is just something you need to remember, that water is always 18.02 grams per mole. Okay, that's 16 from the hydrogen, 2 times 1.01, which would give you then 18.02 is the weight from your water. And so I keep the water all together rather than separating it out as hydrogen and oxygen. So first thing we need to do again, write down our symbols, Na, and I have C, and I have O, and then we're going to have this water here. And the next thing we need to do is we need to write down how many of each we have. Okay, so how many sodiums do we have? 2. How many carbons? 1. Oxygens? 3. And waters? Look for the number that's in front of the water, and that gives us 10 waters. Okay, how much do they each weigh? We need to multiply by that. And sodium is 22.99. Carbon, 12.01. Oxygen, 16. And again, on our water, we said it's 18.02. And that's just a helpful one to remember. Now, let's go through and multiply each of these out. So I have 2 times 22.99, which is a 45.98. Then I have 12.01 for my carbon. 3 times 16 is 48 from my oxygens. And then lastly, I have my 180.20 from my water. Okay, the last thing we need to do is sum those all up, add them up. And so, when you do that, we should get 288.21 grams per mole for Na2CO3. It's bonded with 10 waters. Again, this is what we call a hydrate, okay, because it has water attached to it.